Good morning, class 7th. We will continue chapter 4, that is chemical and chemical changes. And in this chapter yesterday we discussed about the chemical formula and chemical equation and balancing of chemical equation also. And today we will discuss rusting. Okay, so let's start. You may have been, may have seen that the old iron gates, locks, and chains often develop a reddish brown, powdery, or flaky substance on their surface. Okay, this is called rust. Okay, the chemical name of rust is iron oxide. It is formed when iron is exposed or left to moisture, that is water vapor and oxygen in the air. Okay, therefore rusting is a chemical change in which iron reacts with water and oxygen to form iron oxide or rust. Okay, the word equation for the reaction will be iron, that is denoted by its chemical symbol Fe, okay, plus water, that is H2O plus oxygen, they will form iron oxide Fe2O3, or known as ferric oxide. Okay, the chemical equation for this reaction will be 2Fe plus H2O plus O2, Fe2, okay, into H2O, hydrated ferric oxide it is. This equation is balanced also. Okay, now you can see to show that both oxygen and water are required for rusting of iron. Let's do this activity. Okay, material required: 3 test tubes, test tube stand, 3 iron nails, water, oil, cork, anhydrous calcium chloride. Okay, place 3 clean test tube on test tube stand and label them A, B, C. In test tube A, pour some in test tube A, pour some tap water and place a clean iron nail in it. Cork the test tube. Okay, cork means close the mouth of the test tube. In test tube B, pour some boiled distilled water. Place a clean iron nail in this test tube also. Pour some vegetable oil in the test tube to cut off air contact and cork it. Okay, the amount of water in the test tube should be enough to submerge the to dip the iron nail completely. In test tube C, put some anhydrous chloride to absorb the moisture present in it. Place a clean iron nail. Place a clean iron nail and cork the test tube. Okay. Leave all the 3 test tube undisturbed at least for 4 days and then observe what happens after 4 days. Just see the observation. Okay, iron nail kept in test tube A rusts while iron nail kept in test tube B and C do not rust, which means, or what it concludes, in test tube A both air and moisture are present. In test tube B there is no air. In test tube C there is no moisture present. The rusting of iron kept in a test tube A proves that Both air and moisture are necessary for rusting of iron. Got it? Iron is more prone to rusting in coastal areas, whereas the weather is more humid. Rusting can cause a lot of damage to the bridges, ships, buildings, and machines. Rusting can be prevented by the following methods. First is painting. Paint prevents surfaces of iron objects from coming in contact with air and moisture, thereby preventing rusting. Okay. Oiling and greasing. Oil or grease form a protective coating on the surface of the iron object and prevents its contact with air or moisture. Contacts with air and moisture. Galvanization and tinning is also another method. The process by which an iron object is coated with a layer of zinc is called galvanization. A similar process in which metal tin is used as coating metal in the tinning, called the process tinning. Iron parts of machines and cars are even water supply pipes are galvanized to prevent the rusting. Okay. Another chemical change, browning of fruits. Sometimes the cut slices of vegetables and fruits such as apple, pears, brinjals, or potatoes turn brown when left exposed to air. This is called browning. Okay. Browning is a chemical change in which some compounds in certain fruits and vegetables reacts with oxygen in the air to form a brown colored substance called melanin. Browning can be prevented by either storing the fruit and vegetable slices under water or rubbing the cut surface with lime juice. Okay. Reaction between vinegar and baking soda. The reaction between vinegar, that is acetic acid, and baking soda, sodium hydrogen carbonate or sodium bicarbonate, can be observed by conducting a simple experiment. Take some vinegar in glass beaker, add a pinch of baking soda. Evolution of bubble indicates that a chemical change has taken place. The word equation for this chemical reaction is vinegar CH3COOH, okay, plus NaHCO3 CH3COONA plus H2O plus CO2. We can identify the gas by passing it through lime water, calcium hydroxide. The lime water turns cloudy due to the formation of calcium carbonate. This confirms that the gas is carbon dioxide. Chemical reaction for the test is given by the equation CO2 plus COH2 calcium hydroxide. It gives calcium carbonate CaCO3 plus water. Okay. Now we will discuss some physical changes. Okay, till now in this particular chapter we studied about chemical and chemical changes as well as some chemical equations formulas also. Now the physical changes, you have already studied in class 6th also about physical changes. The changes in which no new substance are formed are called physical changes. These changes occur only due to Changes in physical properties of a substance, such as change in shape, size, and state, melting of wax, formation of steam, breaking of glass, and tearing of paper, are a few examples of physical changes. Physical changes may be irreversible or reversible. Okay. For example, dissolving of sugar in water is a reversible physical change, as we can regain sugar by evaporating the water. However, shredding or tearing up a sheet of paper is an irreversible change, as the paper cannot be easily restored to a single sheet. Okay, you can see melting of wax, formation of steam, example of physical change. Shredded a paper, it's irreversible physical change. This is okay. Now the crystallization. A crystal is a solid form of compound in which the atoms are arranged in a definite geometrical shape. Crystals are the purest form of a solid compound. So the crystallization is a method by which a solid dissolved in a liquid is separated from it in the form of crystals. Crystallization is a physical change. Salt is obtained from seawater by the process of crystallization. Sea water contains a large amount of common salt, sodium chloride, along with other compounds and impurities. Sea water is collected in large open pits called salt pans. Using sun's heat, the water collected in the salt pans evaporate, leaving behind the solid salt. The salt obtained by this process is impure and contain many impurities. This impure salt is purified by the process of crystallization. A supersaturated solution of impure salt in the water is prepared by dissolving excess salt to a saturated solution at the elevated temperature. This solution is boiled and filtered to remove insoluble impurities. The filtrate is then left undisturbed for some time and allowed to cool down slowly. Upon slow cooling, the salt particles present in the solution start separating and aggregate to form crystals. The crystals formed are then filtered and dried. Salt crystals obtained by this process are pure and are used for various purposes. Okay, you can see the process of crystallization in this activity. It is also shown over there. Okay, so go through this activity, dear students. Prepare sugar crystals by crystallization. Table sugar, distilled water, beaker, burner, stand, cotton thread, filter paper, glass funnel, and glass rod is a necessary requirements for the activity to perform. Perform the activity only in the presence of an adult. Okay. Take out 100 ml of water in a beaker. Dissolve sugar in the water till it make a saturated solution. Boil this solution on a burner to the boiling solution. Add some sugar in small lots while stirring till no more sugar dissolves in the solution. Carefully filter the hot solution to remove the sugar that remains undissolved and insoluble impurities. Take a thick cotton thread and tie in the middle of the glass rod. Place the glass rod on the mouth of the beaker in such a way that the thread is dipped in the sugar solution as shown in the picture. Leave the solution undisturbed for 2 hours. Allow it to cool down. Observe what happens after 2 hours. Sugar crystals are formed over the thread. A supersaturated solution cooled down. The sugar particles present in it start separating out. Okay, these sugar particles aggregate in definite geometrical shape, forming crystals. Okay. Now, what we studied in this chapter, we will do the concept mapping. Okay. We started with chemical substances made up of matter, atoms and molecules. Okay, the types we discussed: pure substances, impure substances. Impure is an mixture is in this category of impure substances. Elements and compounds. Compounds are chemical symbols for elements. Okay, so the representation is there also: chemical symbol, chemical equation, chemical formulas. Okay, changes around us, physical changes, as well as some chemical changes. In physical changes we studied about crystallization, and in chemical changes we studied about rusting. Then we studied about reaction of baking soda and vinegar, and the browning of the fruits and the vegetables we also studied over there. Okay, so these are some key words, dear students. Try to recall all these words. That will help out to attempt you 1 mark question also. So dear students, in this way we are able to wind up the chapter number 4, that is chemical and chemical changes. So dear students, revise chapter properly and also do the revision of exercise questions of chapter 4. You need to do MCQs, one word or one sentence question answers, answer in brief and answer in details. Okay, dear students, so revise your chapter thoroughly so that you can score good marks. Not only good marks, you can have a better understanding of the concepts that were discussed in the chapter discussion. Okay, so dear students, focus on the revision work for your exams. These exams will prove or make a better understanding of the concepts for you. Okay, dear students, thank you.